Hello everyone, welcome all of you to this lecture. Myself Dr. Ranjana. With this video lecture, we'll start fourth module of our syllabus, right? That is use of free energy in chemical equilibria. It includes variety of topics those are thermodynamic functions, energy, entropy and free energy, estimation of entropy and free energy and EMF, cell potential, the Nernst equation and application, acid-base, oxidation reduction, solubility equilibria, corrosion, water chemistry and use of free energy consideration in metallurgy through Allingham diagram. But before entering in first part, that is thermodynamic part of this module, you should revise quickly some basic terms used in thermodynamics, right? These terms are system, surrounding, property, state function, path function and all that. We'll start with system. What is system? Any system is a part of universe under our study or under our investigation. This system may be solid, may be liquid, may be gaseous, it may be plant or all that. Okay? And what is surrounding? The system and surrounding both can form universe. The part of universe other than the system is called its surrounding, right? If it is the system, then the part surrounding the system is called its surrounding and whole part is considered as universe. It means universe is the sum of system and surrounding. Then come to type of system. System may be open system, closed system or isolated system, right? A system which can exchange energy and as well as matter with the surrounding is called open system. It means boundary of the open system allows exchange of both energy and the matter. For example, in this case, water molecule can exchange between system and surrounding and the heat of the system can also exchange with surrounding. It means both mass, matter as well as energy can exchange with surrounding, right? This type of system is considered as open system. Then come to closed system. What is closed system? These are the system which may exchange energy but not matter. The energy of the system can exchange with surrounding. The temperature of this water can change. The heat can transfer from the system to surrounding. But water molecule present in the system cannot escape from the system. It means it can't exchange its matter. This type of system is called closed system. Then come to isolated system. What is isolated system? Isolated system are the system which can neither exchange matter nor exchange energy. It means this system contain the same amount of matter. They can't exchange the water molecule to the surrounding and also can't exchange heat or energy. The perfect isolated system is not possible. It is an ideal system, but the thermal flask can be considered as an isolated system to some extent, right? Then come to next term, that is property. What is property? Property of the system. These are the macroscopic property which are considered in thermodynamics. Properties are the physically measurable parameters of the system, right? These property can be divided into two parts, that is extensive properties and intensive property. What are the extensive properties? These are the properties which are dependent on the amount of matter in the system. Those property which depends upon the amount of the substance present in the system are called extensive property and intensive property. Intensive properties are the properties which does not depends upon the amount of matter in the system, right? For example, this mass, volume, internal energy, enthalpy, free energy, entropy, these are the extensive property of the system. But the temperature, density, viscosity, refractive index, pressure, etc., these are the intensive property. It means does not depends upon the amount of matter present in the system. For example, if you take a liquid in a container, right, and divide it into two parts, okay, if you divide the amount of matter present in a system into two parts, then density of liquid, temperature of liquid, viscosity of liquid can't change, okay, but volume, internal energy, enthalpy, free energy, mass can change, okay. They depends upon amount, right? Then come to next term, that is state of the system. What is state? State refers to the condition of the system, and the state of the system can be specified by some properties. For example, an ideal gas present in a container, if this is a system and gaseous system, then the property of that gas, that is temperature, pressure, volume and number of mole of gas present in that system specify the state of that system. If you change any property, then state of system will change automatically, okay. Then system goes from one state to another state, okay. Then come to next term, that is state function and path function. What is a state function? Those variable which depends on the state of the system and not on the path through which it has been brought to that state, okay. They depends upon initial state and final state, not on the path. For example, entropy, potential energy, enthalpy, internal energy, these are the state function. It means the state depends on the state only, that is final state and initial state, okay. Change in the state will be is equal to final state minus initial state, right? And what is path function? Path function are those property which depends on the path through which it has been brought to that state. For example, work done and heat. These are the path function, okay. Because if you change the path, then work done will differ, okay. And in the same way, slow heating and fast heating, in these two cases the amount of heat will differ for changing same temperature change, that is changing temperature T1 to T2. If you provide slow heating, then the total amount of heat will be different. If you heat it fast, then it will take different amount of heat. Then come to thermodynamic process. What is this? When a thermodynamic system changes from one state to another, this whole operation is called a process. Okay, there are various types of process. On the basis of condition maintained during the process, it can be classified into these 5. Those are isothermal process, adiabatic process, isobaric process, isochoric process, cyclic process. Okay, what is isothermal process? Isothermal process are the process in which temperature of the system remains constant during process. Okay, it means del T will be is equal to 0. Then come to adiabatic process. Adiabatic process are the process in which no heat exchange takes place between system and surrounding during any step of process. Right? It means Q is equal to 0. Then isobaric process. These are the process in which pressure of the system remains constant during the process. Then isochoric process. These are the process in which change in volume, that is volume change will be 0, that is volume remains constant during process. Okay, and then cyclic process. These are the process in which after completing a series of changes, system return back to the original state. Okay, these are called cyclic process. These 5 are the process depends upon maintaining condition during process. Okay, then come to another 2 division, that is reversible process and irreversible process. These are the thermodynamic process depends upon nature or path of the process. First one is reversible process, another is irreversible process. Then what is reversible process? A thermodynamic reversible process is one that takes place infinitesimally slowly, and its direction at any point can reverse by infinitesimally change in state of this system. If you change the condition, then it can reverse back to the initial point easily. Okay, these processes are in equilibrium considered as in equilibrium at all step, right, and takes infinite time and completes in infinite number of steps. It means extremely slow process are considered as reversible process because ideal reversible process is not possible. Okay, perfect reversible process is not possible. The extremely slow process considered as reversible process. And what is irreversible process? When a process goes from initial to final state in a single step or 1 or 2 steps, it takes place in finite time and finite step. These are the real process and proceed in measurable speed. This reversible process is extremely slow process, but ideal reversible process is not possible, but reversible process is possible. All changes do not return to the initial state by themselves. Okay, for example, if you consider this typical example of an gaseous system, ideal gas system having pressure P1, V1 and T1. Okay, and there is a piston, movable piston. At this place, if you put some particle of sand on the piston, the pressure will increase, volume will decrease, and system goes from one state to another state. If you put the particle one by one on the system, then system goes from state 1 to state 2 in infinite number of steps, very slowly. Okay, if you put all the amount suddenly on the piston, then system goes from state 1 to second in one step only. The second process is irreversible process. If you put one by one particle on the surface, then it will go from state 1 to state 2 reversibly, extremely slowly. Okay, and as you know, the work done by reversible process is greater than the irreversible process, right? Because work done is path function. It depends upon path, right? Then come to next term, that is work and heat. What is work and what is heat? Both are ways to energy transfer. The SI unit of heat and work is joule, right? Both are process of heat transfer. This heat is the random form of energy. This work is organized form of energy. Both are extensive property and path function. Work done on the system is always considered as the positive. Work done by the system is always considered as negative. The same way, heat absorbed by the system taken as a positive, heat evolved by the system taken as negative. These are the some revision part. Next lecture will start with different form of energy, that is internal energy, enthalpy, heat capacity and all that, entropy and free energy, right? And before these, we'll discuss laws of thermodynamics. There are 4 laws: zeroth law, first law, second law and third law. Okay, we'll continue it in next lecture.